Today I'm going to talk about a low battery idiot light that I designed for my brother's car. So the first thing I want to talk about is this voltage divider right here. So the voltage divider basically steps down the voltage to a more useful voltage that I can compare with later. The important thing to know is that when the voltage of the battery increases, the voltage at this node will also increase. As well, when the battery voltage drops, the voltage here will drop as well. Typically, this voltage is going to be around 12 to 13 volts, and this voltage is going to be somewhere around 5 volts. So, the other thing I have hooked up to the battery is this voltage regulator. The voltage regulator is always going to output a constant 5 volts, no matter what the voltage of the battery is. This gives me a very useful voltage that I can compare with later, and then make sure that the voltage on the battery is high enough. So, a key voltage here is 12.1 volts on the battery. When the battery is exactly 12.1 volts, the voltage at this node will be also exactly 5 volts. If the battery increases just even a little bit, the voltage here will be above 5 volts. If the voltage goes below 12.1, the voltage here will be below 5 volts. This is important because this node is connected to a comparator. Now, how the comparator works is if the voltage on the minus pin is larger than this pin, the output will go to ground, essentially. But if the voltage on this pin is larger, the output will go to high. So, when the battery drops below 12.1 volts, this node will be under 5 volts. Let's say 4.9 volts. But since this node is connected to a voltage regulator that always outputs 5 volts, this node's going to be 5 volts and this node's going to be 4.9. Because this one is bigger, the output will go to high, or 5 volts. So, when the battery is below 12.1 volts, the output's going to go to high. Now what happens when the output goes to high is it turns on this switch right here. This switch will turn on a light bulb that's going to be in the dash of the car. So when a light bulb goes on, you know that the battery has dropped below 12.1 volts. Now, what I was told is that basically the light needs to come on when the voltage is between 12 to 12.2. I chose 12.1 volts just because of resistor variance, basically, so the voltage will, even if the resistors aren't perfect, it'll still trigger at a acceptable level. Now, one thing that you could criticize me on is there's no input capacitor here, but I didn't include it for 2 reasons. One is because it adds another component that could possibly fail. Now, this is a pretty low chance, but I mean, hopefully this thing's going to be in the car for 10 or 20 years or even longer. So over a long period of time, a capacitor could definitely fail. The other reason is that a battery usually has pretty low noise. You know, it doesn't have ripple voltage or anything like that, so it's not really necessary. So that's why I didn't have it here. The one thing I really wish I added was a protection diode. So if this thing is hooked up backwards, the voltage regulator and the comparator is basically going to be fried. Now I couldn't add the diode in later because it would affect my voltage divider, and it would just throw everything off. So I just made it very clear to not hook the thing up backwards. One nice thing is this thing uses very little current, and so it doesn't take up much power. Also, it doesn't drain any power while the car's off because the power source is connected to the ignition. So when the car is off, it acts like an open switch. So this thing won't, even if you let your car sit for months, this circuit won't be draining any of your battery. But because the diode right here has a voltage drop of 0.6, that will basically make what the voltage sees here a lot lower, and so I'd have to change all these resistor values to compensate for that. But since I soldered in the resistors before I thought of this, it kind of just didn't happen. So yeah, that's basically it.